Okay, hello everyone. My name is Arthur. I think Fernando and Jakub did a pretty good job introducing the company. I'm not going to do that. So first a quick introduction about myself. I am a senior AI researcher, engineer, scientist, whatever you want to call here at Zeta Alpha. I have a background in information retrieval, search, and AI. I have a PhD from TU Delft on that, and I've been working mostly on evaluation of retrieval pipelines, of agentic pipelines, and embedding models, etc. But now in the last over a year or so, we're working a lot on how do we make the best agents possible for really specific use cases. So if I want to mention quickly about the chemistry agent that we have, like the chemistry specialist agent that we have been deployed that for our customers. They are really happy with that. Apparently they are using it a lot. So much so that we had problems this week with rate limiting on our API keys. So yeah, that's a good thing, I guess. That's a good problem. So what I'm going to talk here today about is basically a meta process that we did to get to this chemistry agent and how we keep evolving that and keep pushing that. I'm not going to be boring you with the specifics of the chemistry, how it works, because don't know that. I just trust that it works, and I trust our customers that they're happy with that and that actually works. And Fernando's girlfriend example is a really good one. So I'm going to talk about not how we get there, but how we're moving past that, because this agent was basically all built by hand with a lot of time and effort. And now we're going to say, okay, this was good for this use case. I want a framework that can get us to a really good agent for every use case, or for almost every use case that our customers control us. So the question is, who optimizes this optimizer? Like, how do you create this optimizer that can create an agent that is generic and good enough for any task? So we began basically, 2 years ago with the RAG. Does anyone knows what RAG is? It's kind of really old now. Everyone knows that, right? So we have a user query. Oh, the laser doesn't work. Nice. You have a user query that sends you an LLM. The LLM can search and a vector search, whatever. That's how most people usually see that. Non-technical people mostly see that. In practice, this is evolving really fast. Something way more like this. Like the user comes in, sends in a question to the agent. The agent spends hours going through multiple sub-agents and you search his memories, external tools, APIs, search the web. Can take hours and hours to get to an answer. In the end, give the user not only an answer, but now actually act on that. Could be like save that to database, send an email, or whatever that is, to actually take action in part of the user. But another question is, you want to be manually doing this? Like, for every single use case that your customer come in that you can think of, you have to come up and think about, oh, these are all the sub-agents that are going to need for this. Is all the APIs, all of the tools, all of the prompts, et cetera, et cetera. Well, this is really hard to make it work for everything, right? You can use something like a reinforcement learning if you have a lot of money, you have a lot of data, you have access to the LLM weights, which is most of the time not really true. And even if you do, this is not really differentiable, right? So if you don't know what that is, basically, you cannot make this into a loss function that you can give to the agent to improve the weights of the model directly. So we move forward to how do we do this without relying on a lot of data and a lot of money and a compute power. So just to get started, a little clarification of terms. We're going to talk a lot about harness today and agent. The strict definition, or more strict definition, that harness is this. It's like everything that is around the agent, around the LLM, sorry, like how do you manage the loop, how you manage the tool calling, how do you manage the state, memory, the cost, access rights, et cetera, et cetera, et cetera. And this is what the agent actually is, or the agent configuration, if you will. What the LLM is, what are the prompts or the skills that it have, the reasoning of the temperature. These are more gray area. Are the tools part of the harness or tools part of the agent? It depends on how you define that. But basically, we now a little bit more of an ad break. We manage all of that for the customers, right? We have our platform manages by default all of the white part of it, and the orange part is a more specific to a specific agent. So that will be the harness, and that will be the agent. But in practice, we're going to use both terms basically interchangeably, right? The harness is what is around the agent, how the agent, all of the tools, all of this prompts, et cetera, et cetera. So let's talk about really how to make this good, how to make it work, right? So have anyone seen this before, the auto research repo by Andrei Akarpati? I mean, does anyone never saw this before? Can raise your hand, it's fine. Okay. Everyone knows what it is, right? So if you didn't raise your hand because you were shy or something, in short, if you actually read this, I kind of hate it because it's so stupid, so simple. It is just a prompt that says, here's my problem, here is how you evaluate it, how good it is, and go and optimize yourself to be as good as possible on that metric. So basically, you give the LLM a metric and you let it write its own code to get better and better and better, and actually optimize that metric that user defined, that you define. And people are getting really good numbers of that, but that's a lot of issues there. Like, what if you don't know how to measure if it's good? And how do you actually make it like general for everything? And it actually assumes that you already have a really good harness. It assumes that you're running this on Cloud Code or on Codex or on a Copilot. That it doesn't give you any tools for your optimizer, basically, for your agent. So this is actually a really hot research topic. So I just grabbed 6 papers that show up in our Slack channel recently from May, June, May, and June, like there are 3 on the same day from archive, all about the same topic. Like, how do you create a really good harness? How do you create a really good agent on the given task? And how these things scale or they don't scale and things like that. So it's a really hot topic that everyone's talking about, but no one's doing that right. I'm going to refrain from making the old joke of teenage sex. So here's one example that we did last year. That was our first foray on that area. We were really focusing at the time on deep research, which is basically you give the agent a question, and you go to find every document that is relevant about that in your internal index, on the web, and it gives you in the end a final long-form report. So we had already a really well-defined architecture for that. I'm not going to go into much detail, but basically have like one main agent in the middle. There's the planner. It's going to grab the user query, make a plan, delegate that to many sub-agents. They're going to search for that. Agents are going to merge that information in sub-reports. That's going to keep doing that until you get until the agent thinks it's good enough, and then write a final report for the user. That works really well, but then there was some papers coming up at the time that say, well, we can actually optimize the prompt directly. Because this was made, like each one of these agents, it's his own prompt, its own tools, that we spent months and months optimizing by hand. And the papers were saying, no, we don't need to do that. We can just let the agent write the prompt for you, and it works well. So we grabbed a few of these papers that was out there at the time. Maybe the most famous one at the time was GPA, that in short, it asks the agent to, you give an agent give the optimizer agent your agent's output, and it reflects on that, create and basically a feedback on that, and ask another agent to rewrite the prompt to improve your previous prompt on that task. If you do if you do it over and over again, you get a really good result in theory. And our main finding was that, yes, it works really well. So we compared, so just to get the idea, the light blue one all the way to the left is an agent where every one of the prompts are like stupidly simple, like one-liner. The light orange one, the third one, is our prompt at the time. And if we optimize the minimal prompt to get to the dark blue, the second one, and if you optimize from our expert prompt, you get to the dark orange one. And we found that, well, GPA works really well. It is even better when you start with a really simple prompt. So basically, let the agent do its job. Don't assume anything. Let it do the prompt for you from start, and it just works really well. Yeah, so we actually compared it against TextGrad, another model to doing something similar that did not work nearly as well. Yes. Sorry.
One point to understand the mechanism. Do you have a ground truth, or do you let the agent decide between?
In this case, we kind of had, so this is a paper that we published in the CIR this year in the workshop. Yes, like it's a public benchmark for deep research that is kind of has a ground truth because it has like a rubric that you ask another LLM to judge your answer. So it's like LLM is a judge directly. But the rubric was like handwritten by PhD experts in the area, et cetera, et cetera.
But the training data set didn't have, you didn't use the training data set where you need the ground truth.
Yeah. We got the full data set, there's like a train split, like a tiny amount of documents that you use to optimize on that. But actually it does well in the test set as well. Yeah.
When you say optimization, it's in terms of the results or the cost?
On the results.
And it comes with additional cost, right?
It costs for you for running the training, but after that, no.
Okay.
It's just like the same agent, the same number. Maybe the prompt is longer, so wasting more tokens, but not really. It's not a big change. Yeah, so basically how it works is like you have a proposer or an optimizer that you give it the agent prompt, a mini batch of a few examples that it can look into, and if it's good or bad, it gives you that a proposer, and you see, oh, this is the new prompt for your agent. Of course, there's a really simplification. If you go to on the paper, there's way more to that. You have like how do you select the agent, how do you confirm if the agent is good or bad, but that's the gist of it, right? You give the agent a few examples, and you can look at that and say, oh, the prompt is good, the prompt is bad, write a new prompt. But we want to do more than that, right? We want the agent to be able to do everything for us. We want to say, okay, write the tools for me. I don't know what the tools my agent is going to need to solve this problem. I don't know what the hardness needs to be. I don't know what it needs to get to the problem solved. So in the chemistry domain, I'm not an expert. I like high school chemistry. I was good at that, I like to think. But I stopped there. I don't know the polymer can polymerize and catch fire. I don't know that. I don't know how to make a good agent out of that, right? So we want to give to this agent something like, okay, this is our candidate, simple agent for simple prompt. I evaluate these answers. I have some trace, the steps that it took to get the answer. I evaluate that somehow with a judge, with an LM as a judge, with some actual ground truth. I give to a proposer, that's the optimizer agent, that can, okay, reason about that, look through the traces, look through the answers, and say, okay, it needs a new tool to actually get there. And like actually write the code for the tools and actually write a new prompt and test it and do it again and again and again. So basically that's where we want to get, right? We get an agent that's like one-liner, and the agent and our optimizer is gonna actually find a good answer, find a good agent for us, explore all possible paths and create a good thing for us. But now it's like, how do we optimize that? How do you create the hardness for the hardnessor? So we are just adding levels of interaction to the problem, right? We want to optimize the agent, but you need an optimizer to optimize the agent, but I don't know what the optimizer should look like, so it keeps adding more and more a complexity, right? So I went through this exercise. Basically, what is the hardness of this agent? What does this look like? This is a gist of what we arrived at. Not everything, but it's like the basic set of tools that this agent has. I'm gonna go through how we get there. So basically, this proposal is really powerful, but I know that people are thinking, oh, why didn't you just use Cloud Code to make this? Because we don't want we want this to be a generic. We want this to work in our customers. We want to use it working in our infrastructure. I don't want to be running a cloud code server instance in our customer database. Go do whatever you want. No, we want to be restricted to actually what it actually needs to do. So we produce this a proposer or optimizer agent that can grab previous candidates, copy files from one agent to the other, actually run a small set of tests. So basically has a hypothesis. Oh, I think this needs a new tool. Okay, write the code for that tool, test the tool, check if it's working, run some smoke tests, evaluate that. Oh, it's good. Yes, cool. No, it's not good. It's broken here. Fixed it, and keeps doing that. And I have memory to actually read any file in a restricted environment to actually get to get a really good number. And most interesting, it has access to all of their previous agents. So if you look at how GPA works, it's a really simple thing, right? At each step, you select one agent, one candidate of the previous on that tab, one previous agent that it already tried and kind of works. You run it on a few queries, and you give it to the optimizer. Say, oh, this is how the agent do. Is it good? Is it bad? I don't know. And just give me a new prompt. It doesn't have access to anything that it tried before. It can't read what the other agents tried. It's just this. Now we're giving it basically, okay, here is the current best agents, plural, that we have. This is what all of them did. Explore them, grab, read that, write the code, test it, et cetera, and do whatever you want to get the good agent. So, any questions so far? Sorry, I can talk a lot. If you don't stop me, I'm going to keep talking. Yes?
Maybe a question on the mini batch size that
Yeah.
Câmara normally uses.
Yeah.
But then the meta-hardness method, do you also first run them on like a small subset and then maybe see if it generalizes?
Kind of. So there's like a gating mechanism. I'm going to talk. I don't know if I'm going to talk about it, but basically, when the agent proposes when the optimizer or a proposer says, okay, I'm done, I think it's a good agent. We test it on a dev set or something, and it needs to be on the Pareto frontier. So basically, we just accept that as a viable good candidate if it is better than all of the other agents on a few questions. So if it's like, oh, it is like the same as something else, then throw it away, I don't care. But it's like, okay, this actually ties with the agents on a bunch of things, lose on others, but win on some. Okay, cool. Leave it there. It means that it is good at something that could be useful. The agent can later go there and read it and merge and combine these two, a new agent with that one to get a better result in the end. Okay.
Yeah, I was just wondering about the judge, because LLM as a judge is also can be flaky, right? Like
Yes.
you run it 5 times, and if you have a rubric from 1 to 5, what really is the difference between 4 and 5, between different runs? So how can you make sure that the optimizer doesn't just basically figure out these kind of weird quirks in the judge, and
Yeah.
you don't actually end up with the best model, but you just get this kind of gun game between the judge and the...
That's a really good question. So in this specific exercise, it was not that complicated for the LLM as a judge to run, because we had like a golden answer. So is this correct or not? Is this answer close enough to this? But I'm going to talk about that in the end, like next steps. What if I don't have any label data? How do you handle that? We have ideas. We have tried that a little bit, and we have a path forward that's going to work. TLDR, you don't compare, you don't ask the agent, is this right or wrong? You give it 2 answers, which one is better? And you go from there. That's the basic idea there.
Does the proposer only changes the prompt or also the harness?
You mean for its own prompt? No.
No, for the agent that it is advising.
It can do whatever it wants. Like, so basically, when you start a new round of a proposer, we give you like a fresh folder with a basic structure and say, okay, this is your agent that you are building now. The other agents are here. Write the code. Do it as a wish. Here. The prompts and the tools, everything, yeah.
Some tool calls can be very effective to agents.
Yeah.
But it can be also seen, I think, that it is going through wrong direction.
Yeah. So I'm going to talk about how to get to this good proposal in a minute, but basically, one thing that I see is that the proposer, if it creates a bad agent, it's just not going to be accepted. It's not going to land in the Pareto frontier, and it's not going to be, it's going to die, whatever. Like it's kind of an evolutionary approach of, if you propose something that is bad, it's gone. It's not going to even be considered in the future. Yes.
Yeah, I want to ask, in reality, how long do you need to run this full circle to get good results? And also the combination is endless. And how do you tune over there?
You don't. You let it run and have like statistical tests to tell if it's actually improving or not. And if you have a measurement, like okay, the performance is going up on this held out set, on this test set. It's basically how you do with any machine learning problem, right? You have this hold out test set that you can see, okay, it's actually improving. And you control the exploration by this Pareto frontier, so you just throw away bad things.
Yeah, like how expensive would it be?
Depends on the data set as well. Like if it's a really big data set, it can get quite expensive. My boss is here, so he's the one paying the bill. I can't say how much it was. I'm kidding, but like each round's about $50, $50 to $60, depending on the data set, on the agent on the model you use, et cetera. So sorry, I want to keep going because otherwise it's going to be stuck here forever. There's more to talk about. We can talk about later afterwards as well. But in practice, who optimizes that? Who decides on this harness for a proposal? Like who decides on this thing? How do you get there? Spoiler two. You have to know what's happening. You have to have some level of control over that. Because there's a lot of things that you need to think about, right? How do you control the environment that your proposal can run? Have basically sandboxed it in a way that it doesn't really have free reign, especially when we're talking about enterprise settings. Like it needs to be confined somehow. You need to know how you're storing all of the traces of your candidates and the proposer as well. How do you score them? How do you split that in dev, train, tasks? How do you create these tools for a proposer? How to do with costs? How do you accept one thing or not? Like that's what you say, like about this Pareto frontier idea that you just accept a new agent if it actually is good at something. How do you manage these experiments? How do you measure the statistical significance? So all of that are things that you need to think about to actually create a good proposer, a good optimizer. You have to manage all of that one way or another. Of course, you can use auto-research. Sure, using cloud code, whatever. But that's not going to scale in like enterprise settings. It's not going to work in like an industrial level thing where you have to have all of these controls, have a statistical rigor, and actual control all of these things properly. You can probably start from there, but still there's a lot of extra stuff that's just not that straightforward. So how was our experience? Well, mostly my experience building this. Your mileage may vary. So I was working with Fable, Opus, to get there. Until Anthropic said no, until the US government said no. Cool, now Opus is helping me. I had some really good experiences. So Fernando mentioned that we switched recently from from Copilot to Cloud Code. So yeah, Ultra Code, let's do it. Yeah, go for it. The good thing, it was really good at implementing stuff. The code was right, the code worked. Created a really good starting point for that. Good at finding new data sets. So say, okay, can you find other data sets that you can verify, that you can check? I have all of these papers that I have read. I don't know what should I take away from that. Actually, apply here, give me the summary here. Implement these evaluations for all of these data sets that we want to use. That was really good. Creating this, I have this new data set, hook it up for me. Grab the data from I don't know, Hugging Face, some weird website, set up the evaluations for me, make it work. Yes, it works really well. And actually, I think that was the best part for me. I could just let it, okay, I'm going to bed, run this for me, have a budget of $30, let me know how it goes. And it works. Like next morning or 2 a.m., if I wake up because my kid woke me up, just check, oh yeah, it crashed. And it already fixed it for me and it's already doing it again. That was really good. The bad part is 90% of everything that it said, oh, this would help, was trash. It did not work at all. Like the idea on the face of it, yeah, this could work. Like it's a new tool for the optimize for the for this proposer. Maybe it would work. No, it doesn't. It's all crap ideas. Nothing worked. It was absurdly bad at actually reading the logs. So if you just scroll through the logs of a proposer, you could see that it was struggling with something, and it kept not doing that. Like it would grab one thing or the other, but not find any obvious fix that for us, like obviously it's trying to do this is not working. It needs a tool for doing this. So much over-engineering. It's like, okay, it's just a one method, just do this. No, it's a whole class, a whole thing. No, it's simple. Over-engineering a lot. Generalizing. Every time you try to hook up a new tool, it will do it for you. But then every tool that you had built before for a proposer would just be basically hard-coded to that other data set. And now all of the tool responses were just crap, and you just not grab it, because it could not read the logs. It said, look at the logs and find me what's wrong. Oh, it's right. No, it's not. It cannot read anything, like the data is broken. I spent 1 hour fighting with it while I was in my kids' daycare Father's Day thingy. I was like there, like, no, just implement this properly and check it's broken. No, it's not, it's not broken. It is broken. I can say it's broken. Just test it properly. Oh, yes, you were right, it's broken. I know it. So anyway, and it kept cheating. It kept trying to cheat. It kept asking to propose, to add things to a proposer that would just give the answer. So there was one data set that the answer was, I knew it, I knew that was the answer. Like, you could basically just grab the data set somewhere online and just put it there, and it's going to find 9% of accuracy. I know that was the goal, but I don't want it to give the answer to a proposer. I wanted to give the tools for the proposer to find that out by itself, so it could be like generalizable for any use case. It kept changing the prompt of the proposer by itself, without me asking, just to give it the answer. Even worse, it tried to put things in the agent prompt directly to give you the answer. Many times, I had to say, do not edit the agent. Do not edit the proposer. Do not add the answers. If you're doing this in a public benchmark, whatever, just invalidating all of your answers, right? You were cheating. So it kept trying to cheat, and I said, do not cheat. So the numbers, the results. Well, it works. In the end, it works. So it was maybe 2 weeks of effort, and we got to a point where a proposal will actually work well. So this is again focused on the chemistry data set, a chemistry, biochemistry domain, all starting from an agent with no tools, nothing, just like a GPT 5.2, I think, vanilla, nothing. The same learning that we had with the GAPA before, that if you start from an empty state, it's better than starting with something already built. Let it run, and it gets a really good result. So this is like just for, I'm not gonna go too much details here, but basically the red line is the test set, the actual test data that the agent does not see. And the blue is the dev set. So we're running on the dev set. Every time it makes a new agent, we check it on the dev set that actually does not see, but is used to gate whatever is kept or not. And after a few rounds, we evaluate on the test set. That's the red line. And it improves a lot. So some of the so the first one to the left started like 30% or something, 35, got to 68%. So 66 to 71. That was already a benchmark that is kind of saturated, so it's already hard to get much more out of that. And there's some broken questions. The answers to the questions are wrong in the benchmark. But anyway, yeah, this one like 42 to 70%. This is still running, so I just like a snapshot. So it got from 49 to 54. So but it's still going. So it's still going up. So yeah, it works, right? We give you like if you have a good harness for your proposer and a well-defined task, it will get you a really good agent in the end in a restricted setting. Main find is that, yes, start from a simple agent. Let the optimizer do its job. Don't, or like, let the AI do its thing. Is the beauty lesson, right? Don't think you're smarter than it. You're probably not. Not for this. This fully automated pipeline will get a really good results in the end. So the agents that it actually made here, like in the end, it's like multi-agent setup, like with sub-agents. It has really specialized tools for chemistry, like tools using like some Python packages that I kind of knew that it could use, so was already in the environment. Like you were actually writing code for that package without knowing that it was in the environment, and actually writing good code using RDKit, some other specific things, fetching data from the web without being told to do so. Yeah, it actually created really good tools, really complex sub-agent structures that actually works. And the high leverage gains are in the hardness of the optimizer. So sometimes like it's not working, it's not getting better. What if I give it this tool? Boom, it works. It gets better like a jump, okay. So the hardness is the most important. It do not give it to another agent. Kind of a paradox, right? You are optimizing an agent, you cannot optimize the optimizer, but it's true. But there's still a ceiling of how much you can do in a fully agentic setting. It can generalize from multiple similar benchmarks. So if you have a good optimizer that you know that works in a specific type of question. So for instance, this one, we know that it works really well for chemistry and biochemistry data sets. I don't know if it works well for other domains, this optimizer. Probably yes, but I don't know. I can't tell for sure, but it probably works okay. And the meta harness workflow is basically let the optimizer run. Manually inspect the traces. Do not trust Fable. If Fable cannot do it, GPT 5.5 can do it. Opus cannot do it. Look at your data. Like, don't trust it. Look at the data. Look at the traces. The important part is log everything and look through it and make sure that you actually understand what's happening. Change a little bit at the harness. Don't cheat to get to a good place. So yeah, this whole thing is a little bit weird, right? Why we cannot let the optimizer, why can I not trust Claude, Fable, whatever, to make this good harness for the optimizer? My hypothesis, like a supervision signal issue, right? If you have a benchmark is easy, you have this number that goes up. If number goes up, results good, keep going. But I have like this extra layer of interaction, and that's why it was trying to basically cheat, because it was trying to get the final answer better, but it was no, optimize this thing, not the end result. So it's like an extra layer of interactions to get to the good number. So it's a distant and a weak signal. Like, is this optimizer good at optimizing other agents? And the follow-up question, like, what if we don't have labels, right? So in this specific case, we had labels. We had some other experiments going on that is no labels. We have a direction. We think it's going to work really well, but follow-ups. So LLM as a judge can be a good thing. As you mentioned, like, you're just adding more errors to the pipeline if you do it naively. But LLM as a judge with some weakly supervised signals and some smart ideas like the pairwise judges, that could actually work well. And we have some signal that it actually works well. Yeah, so the summary and the next steps, well, it works. If you have a clear goal, a strong proposer can do actually really good results. This is basically a hill climbing algorithm, kinda, on operator frontier. Starting from a simple agent is better than a complex one. Human in the loop is still important. You do not trust an optimizer to create your own harness. Use your brain. Don't delegate everything to Claude or to whatever. Look at the data. Understand what's happening. And basically, my experience is that you do the thinking, the AI, Claude, whatever, write the code, but you do the thinking. Don't let the agent do it for yourself. It's not going to work. Yeah, and this whole unsupervised issue, like LM as a judge helps, but there's this bias that keeps compounding. And now you also have this another optimization target, like another moving target. How do you optimize the judge? Again, we are working on that. We are getting some numbers there, but not ready for prime time yet. But we'll get there. Okay, I think I've said a lot already. Yeah. Thank you. Yeah. No, sorry, in the back. Yeah.
So I have a question about the second part of the title.
Yeah.
So there was Jetpack can outperform reinforcement learning.
No.
No?
I didn't say that. I said that reinforcement learning is a good idea if you have the data to do that, if you have access to the weights, which is not always true. If you're using OpenAI, you don't have access to the weights. You can't tweak the weights of the model itself. And if you have the time to compute the budget to do that, right? If you can do it, it's probably better than just trying to do prompt optimizing. Meanwhile, JPO I find it's really good if you already have, if you predefine the agent architecture already, and just want to optimize only the prompts, that works well.
And genetic evolution?
Yeah, Pareto frontier, yeah.
Did you consider, for the crossover mechanism?
Yeah.
What was the mechanism that you considered? Did you consider alternatives for the
Yeah.
crossover that work better?
It is indirect, right? It is done indirectly in the GPA, it has its own thing. We're not talking about a proposer architecture that can actually write code, etc. It can do it indirectly because every time it runs, it can see it can see which agent is the best one at each question. It can inspect the logs. It can inspect the code of any past agent, any past candidate. And you can actually merge candidates as it be. So you can copy, oh, this tool was good. I'm just going to copy this tool here. This tool is bad. I'm not going to do it. I can read that prompt, and combine them as it wishes. So like, it's not directly not implemented as a genetic algorithm, but it works almost like it. Yeah, sorry. Yeah, go ahead.
I had a very similar question.
Yeah.
And one of the questions was if each new optimization is happening only by changing only part of the whole, and measuring only small improvements. So a bit like
yeah. So each step, the agent can do whatever it wants. So it can do, we set a limit on how many rounds you can do, of how many turns you can get, how many messages you can send, basically. But you can call multiple tools at the same round, that's fine. But in the end, it had to like a finish tool. Like, okay, I'm done. okay, cool. Now our harness is going to grab that agent that you have made, evaluate on the dev set. If it goes on the frontier, good. It's going to be added to the leaderboard. Otherwise, throw it away, and then handle it back to the agent. Say, okay, it was good. Here's the new leaderboard, or it was bad. Here's the current status.
And when you run it, based on what initial, like you have a seed, a random,
Yeah.
And it can go and change everything. Or it can change only something, and that's it. So
Yeah.
the agent has the
Full reign. Yeah, we started with a seed agent. In this case, it's just you are what's that like? You are a smart assistant, basically. That's it. No tools, nothing. And okay, this is the agent. Here's the configuration in the format that we support in our platform. Do what you want. So someone at the back didn't ask anything yet. Sorry. Yeah.
Yeah. So I have two questions. The first one is the model for the proposer and the actual agent, are those the same models in your experiments?
No. So no, because so that's something that we want to do. That we for this specific, we didn't do that on this experiment, but the idea is that you can use a really strong model as a proposer, but use a weaker model as your target agent. In reality, in this case, the agent can do whatever it wants. It could change the agent's model. Like it had access to the effort level, to the temperature, to everything. You could just say, no, this is 5.5 extra high. It could do it. I don't think anyone tried to, but it could. But in this specific case, the starting point at least was a proposer 5.5, GPT 5.5 high, I think, or X high, I don't know. Target agent 5.2, so it's a bit cheaper. And if it created any sub-agent, by default, it was 5.2 mini, so even cheaper. But it could have changed if you wanted to.
I think it would be interesting to see, like, if an agent can sort of, this goes back to the question of, is verification easier than generation? It'd be curious, like, if an agent can verify its own traces, even though it would not be able to do it, correct?
Could be, yeah. We could just say, okay, now you do it yourself. It could work. Yeah. Going back to the front, yes.
So when you were discussing about the optimization and how you basically let the agent optimize itself until it evaluates and it says like, oh, this is good enough. I'm thinking about the context management and the amount of context that it uses. So how do you handle the context rot of, I have this agent that is trying to optimize this other model. If the task goes for a long amount of time, how do you handle the context rather than damaging the optimization that it can make?
That's a good question. So this is part of the harness that you're talking about, right? So how do you manage, this is part of the harness though, how do you manage the context? We have two answers to that. The first one is how our platform manages that. We have our own way of managing that. So it's basically, Fernando can talk more details later, but it's basically, after some point, you just don't drop anything, but we just say, okay, those are tool call here. If you want to see the data, go find this file. So basically, we just compress things, but not like Cloud Code does it. I just drop too long things to make it shorter. In this specific case, what I did, and this a proposer was not, the agent that it was optimizing was based in our platform SDK. A proposer itself, no, was just like generic OpenAI code, like nothing, our own internal things. One of the tools that I gave the idea, because Opus Fable would not figure it out by itself, is that, okay, some tool calls that the agent is doing have like 5,000 lines of code, like no, don't do it. Instead, if the tool output is longer than 1,000 characters or whatever, dump it to a file. The agent can do grep, can do cat, can do head, tail on that file directly. So that already helps. So if the tool response is too big, dump it there. I didn't get to a point where we actually blow past the context length of 5.5, because I think it's 1 million tokens. There are also other stuff there, like the every new round, don't give the full tool output, just give pointers to what happened before, so they actually make it shorter in the end to save context, but it was not a problem. Because if you have a limit of a budget of like $50, $60 per run, you're probably not gonna hit the full context window. So in the end,
So if you look at the trajectory of optimization, you see it's very fast. It
Yeah.
boosts performance, but plateau very quickly, right?
Yeah.
And in that sense, can you say that if you just make the agent to do this optimization agent, just try to make it itself, you can bypass this whole optimization phase, because immediately it gives you very good results, because the optimization doesn't change that much if it's worth effort to actually go through that path.
Kind of. What actually happened, if you look at what actually happened under the hood, is that the first round, it has nothing. And the agent produced a lot of stuff in the first round. Like usually has produced like 2 or 3 new tools, change the prompt multiple times. And that covers, is like the Pareto optimal principle I have. In this first step, this first few tools cover most of the data set, right? And the upcoming rounds, what the proposer is doing is basically patchwork. Like, okay, these are the cases, these are the edge cases where my initial proposal did not fully cover. So it's like, okay, this is a corner case that this tool doesn't cover. Let me change the prompt here. Let me add this edge case. Let me add this another tool that covers maybe 2 or 3 cases, but still important. So could be that you could just, like the own agent do its own thing. That's what you're saying, right? Basically,
yeah. Like basically, it's no optimization, just let cloud code or something figure out how to build this agent themselves.
Yeah, the problem with that is that, like first, if you just let cloud code yourself, the problem of it already knows the answer because it can see the test set, right? It will be cheating. It has access to the test data. It's in the context and just look at that. The other problem is that we could not deploy this in production anywhere, basically, and super expensive. So basically, the trade-off is instead of letting cloud code do this optimize thing directly, I want to have a good harness that I can apply to everything, to any other problem. Sorry.
So just to understand that, do you, for the proposer can see the full history of all the variations?
Yeah. Yeah.
And you said that you haven't reached the context limit.
No, because it's not like everything is in its context. It says its files in the file system, and you can grab it if you want. So if you say, oh, I had this question that the last proposal did not get right, let me see in the past agents who got it right. So I can put it there here. So just grabbing the right part of the file should just copy that.
But still, each variation can go all directions.
Yeah.
So is there some like a rule of thumb to help the proposer to regulate the proposer to go into push into the right direction? Otherwise, they can just
Yeah,
go
that's this gating mechanism that I was talking about, right? So the agent proposes a proposer makes a new agent, and then we say, okay, I'm done with this agent, evaluate it, and then we evaluate it, and if it's not landing in the frontier of the best agents so far, we just throw it away. So basically, it's this pruning mechanism that every round, we just accept a new change if it's actually good. If the agent proposes something that doesn't help anything, it just goes away. So it basically self-prunes as time goes.
So those pruned away runs are not in the
No.
traces.
No.
That's
These are going to be, yeah, these just go away. Yeah. There's one more question because it's already 7:30, so we can talk afterwards. So, yeah.
So I'm just curious how you made the optimizer harness. Did you use something like Bimono, or did you make it from scratch completely, or how did you do that?
For the agent itself, we have our own SDK for agents that we use in our platform. That's what I use for it. For a proposer itself, for now, I made it and Cloud Code made it by hand. Basically, everything's managed by ourselves, but the plan is to migrate this to our platform as well. So this will be available to our customers.
Yeah.
So it was all made with Python.
Yeah.
No. Yeah, that's one reason why we have our own SDK, because all of these other things, length, fuse, length, these are all so bloated, so much stuff that you don't need. I just need a small stuff. I don't need to be importing all of this crap. I just need some stuff. So we'd rather build it ourselves, what we actually need. Okay? Thank you very much.